Most of you already know our first speaker. Dan Kaiser is Associate Professor in the Department of Soil, Water, and Climate at the U. His primary areas of work include fertilizer guidelines for commodity crops, nutrient cycling, and the development of precision ag technology. So Dan, welcome.
So good morning, everybody. See the caramel rolls are out back, so hopefully nobody goes into a sugar coma this morning, but it's a good time to do it during my talk. So, this morning, what I'm going to talk about is some of what we have behind our current fertilizer guidelines. I mean, I've given this talk partially before, but ultimately with the guidelines, it'd be nice to have something that's tailor fit to every grower, every field in the state of Minnesota. The challenge of it really is having the data behind that to start looking at trying to be more specific on our guidelines. And that's been one of the challenges for me, looking at the fertilizer guidelines for as long as I have is, how do we do this? Particularly when we start looking at planning purposes, when many of you, if you're making a decision on nitrogen management, a lot of times some of that decision is being made when you're pre-booking fertilizer, in late summer. So we're looking at a situation where we're, more than 6 months out before that crop goes in. And the challenge to me, with a lot of when it comes down to a lot of these nitrogen models, as many of them factor in weather, and that's one of the big things. Looking at a lot of our guidelines, if we could, or we had a good idea of what was going to happen that next year, I think we could be better at tailoring our guidelines to specific conditions, and that's been kind of the challenge in the planning purpose, particularly for all applications. I mean, how do you really know with that? So, looking at situations why we've still stuck with some of these systems like the MRTN, which is getting up there in age. I mean, the maximum return to nitrogen approach started. I remember it when I was probably a master's student. That's been getting on 25 years ago. Starting to talk about that when Dr. John Sawyer and Emerson Nafziger, or John at Iowa State and Emerson at Illinois, were looking at ways to start managing nitrogen, specifically looking at economics because of fluctuating fertilizer prices. And that's really, if you look at why these things were developed, for one, there was a lot of discussion at the time for looking at across state lines, which I know it's still an issue with some people, that if you're managing fields fields on the border, that we saw a lot of differences when it came to our nitrogen recommendations. So, the idea here wasn't to have a one-size-fits-all recommendation across the region, but it was at least to start honing in a little bit better on our terminology and at least having a similar approach. And that's kind of what we're doing now with P and K as well, just to try to make it hopefully a little easier so people know what things are when we start talking about some terminology and some other things within our guidelines, that we have at least some consistency near state lines. Looking at it, prices were a big thing. Although if you look at the data and we start talking about price ratios, most fertilizer historically, the price ratio is moderated. Well, whether it's nitrogen, phosphorus, potassium, it's been around a 0.1 price ratio. So about 40, 50 cents per pound. Are we good, or do you need to adjust?
For everybody.
So it's been, more in recent years, particularly like phosphorus now, which it's still closer to a 0.2. Nitrogen, if you look at it, a lot of our numbers were closer to a 0.15 price ratio. So we've been seeing more volatility as of late. So the idea here then was at least have something where we could adjust should nitrogen get, fairly expensive. But if you look at the adjustments, they aren't really that big in terms of the total number of pounds. So there is some adjustment, because we know with nitrogen, and kind of when we show out some nitrogen curves here, is that we get to a certain point where we're not gaining as much in yield per pound of N applied. And that's really what a lot of this is really trying to adjust. And then, corn yield, that's the bigger question, because most of our older systems were a yield goal-based system. And as yield increases, technically, then with a yield goal-based system, that we should be adjusting our N rates, but we haven't really seen that as much. And a lot of that, if you look at the corn, has come from a dilution of the amount of nitrogen in the grain. That if you look at the total amount of nitrogen being taken up now versus it was, 20, 30 years ago, the amount of nitrogen per bushel has decreased, where the total amount of N, while we've seen a little bit of creep in the uptake, it hasn't been as much you would generally expect with the increase in yield. And that's been just because of the dilution of nitrogen in the grain relative to starch, because we're breeding for starch and not protein or nitrogen in the grain. That makes a big difference when it comes to nitrogen requirements. I'll be kind of curious to see, as we start seeing short corn too now here, what's going to happen with that. Looking at theoretically if you've got, depending on how much biomass you have, if the amount of nitrogen is the same, the concentration per unit biomass, less biomass will be less N uptake and potentially less need. But what we'll kind of see with that, because I haven't really seen any data on that at this point in time. So the maximum return to nitrogen, it's a database-driven system. That's one of the things I do like about it. It's because we can input data, new data, we can take data out. I'm constantly evaluating things. Generally, about this time of the year, I'll start putting out a call with all the researchers to try to start gathering as much nitrogen response data we have. So we can look at, and a lot of times what I'll do with that system when it comes to the database is I'll start plugging the new data in, and then I'll take some of the older data out, and I'll kind of look at some different scenarios as we start seeing things change, because we have seen, I took this over just a little over 10 years ago, working with this in Minnesota, and we have seen some increases. A lot of that has to deal with the number of sites we've added. It's one of the things with the database, the more site you have, particularly newer site, relative to the older sites, tends to skew things towards the newer end. So that's kind of one of the things with it's difficult for me is that I'm going through this data on a yearly basis. I'm going to make some decisions on what do we keep and what we don't keep. And I'll kind of talk a little bit about that because I did change things, particularly for the continuous corn. I'll show why, because I've got a nice graph that shows that response over time. But the nice thing is, when I look at it, at least it's defendable because I know I have some real world data behind a lot of this, where if I have a state agency or somebody else that start coming up and asking me about where our recommendations come from, we can actually go in and point to where some of that data is. So one of the challenges with this is when it comes to this database is the amount of data that's actually in there, and that's been one of the things that I've had requests from people looking at making crop models to start digging into this, and we don't have as much data in the database as we probably need to if we start looking at, you start talking about AI and what you can do in terms of looking at patterns in data. It would take a larger shift in terms of what we're collecting, particularly on the climate side, because a lot of what we have in the database really is just response to N, where the site kind of was located. I do have a site identifier, maximum yield response, grain yield at maximum. There's a minimum amount of data, and I'll show some of the things that we can output from the database itself. And then just a little bit of information on the site, the soils. Was one of the things I am looking at now in the state of Minnesota is doing a split in the state. It mainly would affect anybody, though, managing crops in the far southeast, because I've finally got about enough data where we've got a critical mass to start splitting some of this out. But there isn't as much there as you think there is, and that's one of the things that even in what's online, looking at it's just mainly the equations, because that's really all we need, essentially, is we need the equations that were developed looking at the nitrogen response within an individual field for the estimates to look at developing the database itself. And instead, I'll talk about this here in a moment. The trials themselves, a few strict things when it comes to what we're looking for. It does become a little bit difficult when we look at on-farm data, and I have been working with some programs through the Department of Ag, their nutrient management initiative. We've had some level 2 sites across the state to try to boost some of the database and to kind of get into some information that would fit with some of these criteria where we have multiple replications, 5 to 7 nitrogen rates. A lot of my newer trials, we were doing at least a minimum of 6. I like about 8 rates if I can get 8 rates, because the more gradations or the smaller increments of increase you have, usually the better your data is. And that's the challenge. When I look at a lot of data, when it comes in on a yearly basis, if we only have 4 nitrogen rates or 5, it becomes difficult to me to get an accurate estimation of what the optimal N rate is, because you've got such a wide, generally range in your steps are to get to the rates you need. Because as of late, some of our sites with some of the rainfall we've had. I mean, we've had to really increase our max N rates in some of these trials just to make sure that we can at least get a good estimate of the return to nitrogen. It's not uncommon anymore for me to have upwards of 300 pounds or more in some of these sites just to make sure that what I really like to have, if you've got 6 rates, is, at least 2 above the optimum rate and hopefully 2 below to give a nice response curve. With then becomes difficult the fewer rates you have. But that's one of the things for anybody doing on farm. If you want to look at it, there's ways we can do it. It's just having the space and being able to put enough rates in place really to get good data is the challenge. I mean, the other thing that I have a challenge, particularly for on-farm trials, is MAP and DAP, is how do you credit that? We've been doing, and I don't have anything specific to that NMI Level 2 program, but that's always the challenge with that is when we get the data back, I've got fall applied MAP, DAP, and then maybe some AMS that applies 40, 50 units of N. Do I credit that or not? Because if I credit it, I mean, it's probably overestimating the MRTN. If I don't, it's going to be, it's going to affect it either way. So that's kind of the challenge with on-farm data. Nitrogen, it isn't as easy. So that's why a lot of the stuff in the database, while we do have some on-farm results from some of those programs, a lot of it's just, it's really pinned down, or it's really focused on the small plot studies. So right now in the data set for Minnesota, I really need to get in and start compiling irrigation data because I know Vasu's got some data, Fabian's got some data that we can start looking at adding an irrigated site. I mean, we did look at irrigation back, it was around 2015. We only added recommendations for the irrigated corn on corn because it was more consistent than the corn following soybean. If you looked at the data set, we had more data and it was more clear for what that MRTN is. But now I've got close to 10 or 11 years more of data beyond that we could actually look at probably adding that in and looking at, what I'd really like to do is compare it to some of the Wisconsin data because we've got a lot of similar soils in some of our irrigated regions. Corn following soybean, corn following corn. It makes it a lot difficult for any of you that have anything in the other than that in the rotation. Really looking at nitrogen response. One of the big question marks I have right now is cover crops. You start adding that additional crop in there. I mean, how does that impact things? It becomes kind of a challenge because then using this system, since the numbers are really geared towards specific rotations, it's really hard to know how to make a decision how to adjust things if you change that rotation. And that's, we've got some general ways or recommendations for that, but I mean, there's kind of some question marks here because since a lot this is data driven, it's really dependent on real world data that's collected at a specific rotation. So theoretically, if I wanted to look at corn following dry beans or corn following potato or some other crop, I mean, really I need more sites that really test that to look at developing the MRTN. And that was a challenge when we looked at corn following alfalfa. I used some of the data that Jeff Coulter had compiled or looked at doing a large meta-analysis of data to look at that. But there just isn't a lot in some of those rotations that we can, because I'd really like to have a critical mass of number of sites before I look at putting together something for online for release to the MRTN. So again, metadata, I mean, we are a little thin. Within state geographic region, Minnesota will likely see a southeast versus what we call Maine, which will essentially be everything outside of the karst region. I don't have anything, if anybody is north of 94, you get up to the northwest part of Minnesota. I typically recommend most people look at the western North Dakota recommendations because we did collect some data up in that region, but it's compiled within that western North Dakota recommendations. So there'll be maybe start seeing some splits in the data set here in Minnesota because I'll show the data. There are some differences now. If you look at the southeast, when I did this maybe 3-4 years ago, I gave the same or similar presentation. You look at the data, there wasn't a lot of difference. I mean, there might have been a 5-pound difference between the two. So there wasn't really any need to go in and look at different recommendations. But, as we add more data in there, we get a critical mass, we can make some recommendations. And I'll talk about that because now we're seeing a little bit more sizable difference between the two that we could look at differences in the recommendations. So, what we do in this, collect the data. I look at the end response data and we compile it. I mean, this is kind of this is Iowa's data. I mean, I just use this one because it's an example. I can do the same thing for Minnesota. I mean, this is essentially looking at all the nitrogen response data. This is through 228 trials. This was probably 5 years ago. I mean, we have around, I believe, close to 200 trials in Minnesota, and you're going to see a lot of the same thing. I mean, you see here is on the left is corn grain yield in bushels per acre on the left part of that axis and the nitrogen rate. So again, nitrogen response curve, you see pretty similar curves. No matter, you look at some differences in yield levels here ranging from on the lower end 150 up to 250 pounds. And that's really what we've been seeing with a lot of this data is, I'll show some of this. If you look at, looking at tying in specifically with yield, is that it's not as good of a predictor as we'd like to see. So that's why we're not recommending it, at least for planning purposes, because we can see such a wide range in rate. And really the calculator itself is really not as focused on maximum yield potential. And that's kind of one of the things when it comes to economics is we're focusing on what we call the marginal return, or the return per pound, every pound of N applied, looking at whether or not we can at least cover the cost of N. So whether or not it's actually profitable to grow corn in these areas of the field is another question entirely. And that's really kind of more begs on that maximum yield potential itself. So when it comes down to the calculator itself, again, we're just focused on response to N and not necessarily on overall profitability, because that's really what we're trying to make sure is that we're getting at least a good return to whatever we're applying. So the calculator, I've got a way to do this. I've got an Excel file. What it does is you plug in the coefficients for the nitrogen response, and what it does is it'll calculate a few statistics for each pound of N applied. It'll calculate cost, it'll calculate the yield, then it'll look at N return, and then what it does is it'll take each individual site and it'll average that calculation of those estimates over all those sites to give me just the simple graph that I'm going to show you here in the next slide. And then again, we can adapt it for the rotations. I mean, it's typically what you see across states. Some states will be more split. I know Wisconsin has a few more splits. Iowa has, I think, 2. Illinois has 3, although Iowa's no longer in the calculator because they're kind of looking at some of the the modeling. So if you're looking if you're near the state border, you're not going to find that data anymore. And then the N rate with the largest average return to nitrogen is the MRTN, or the maximum return to nitrogen rate. You'll hear a couple different terms we talk about, MRTN or maximum return to nitrogen, or sometimes you'll hear me say economic optimum nitrogen rate. They're roughly the same thing. So essentially what it's looking at is, kind of where that green dot is, that peak on the curve, essentially where we see the maximum return to N. And this is really all we're calculating in this MRTN is the yield return, which is the dashed blue line. The green line is just the increase in fertilizer cost as we get just a steady increase in per every pound we apply, and then you subtract the two and you get that curve in the middle, essentially, which is the return to N curve. So the green is the MRTN. The two red diamonds, those would be what we call the profitable range, because we do know there's some variation out there in fields. So there's a goal of this to not really fixate on a single MRTN value, but to at least to provide some flexibility when it comes to grower goals. If you got an area you feel that's more responsive or less responsive, to make some adjustments. I mean, the issue with this, though, if you're dealing with variable rate nitrogen, doesn't really work so well, because again, it's just a single point with that. And even with that MRTN range, there's always some questions on what to do with it. And within the calculator itself, you can look at some different price scenarios. I mean, this is just showing different price ratios from 0.05 to 0.2. In my table I'll show at the end, I've adjusted these a little bit more to tailor, makes it a little bit easier with fertilizer prices. I'll talk about that. I don't list the 0.05 anymore, just because you never really get to that point where nitrogen's that cheap with it. But you can kind of see how things adjust, and the calculator itself will also essentially look at the data set and calculate out where the yield is in relation to maximum yield. So to give you an idea of kind of where that MRTN rate is, and that's where it is in terms of the yield response curve for maximum yield. Typically, a 0.1 price ratio, you should be at 99% on average maximum yield. So there's looking at maybe a 1% loss in yield with that. And again, looking at that, just because when we get that curve flat, your return to end starts to get lower. So again, that's really what we're focusing on. The problematic area is really when we get to that lower curve, and that's high price N. I mean, it does adjust back a fair amount, and you'll see that MRTN, that rate window gets a lot narrower the more expensive the fertilizer is. That's, it's pretty common with that, because it's, generally plus or minus about 10 pounds for that. We're plus or minus $1 from that MRTN value within that rate window. So that's really what that rate window means. It's essentially just assessing the fact that we know there's some variability out there in field to field, that a single value may not necessarily be accurate. And if you've got areas that you might feel that are more or less profitable, there's some adjustments that can be made just within our data set. So currently in Minnesota right now, we have corn following soybean. We have 211 sites. I don't have this split. If we do this split with Southeast versus Maine, we'll have probably, I think, around at least a quarter to a third of the sites are probably more Southeast, more silt loam oriented. So it'll change it slightly, and I'll show you where the numbers are. Potentially if we do this change. Continuous corn have far less sites. As of late, we've had far fewer corn on corn fields. But I've also thrown some of the data out through about 2000, and I'll talk about why that is, because looking at the yield increase and looking at the response to N, I've got the yearly averages. Continuous corn has been the one that we've seen a fairly steady increase, and that QR code will go actually to the new site. It's cornnratecalc.org, but if you just search corn N rate calculator, you'll actually go to the current site that's out there. We moved it off the Iowa State server because of retirements, and we've got a private company that's been maintaining the site for the last 4 or 5 years. So a few things to remember. We don't have a credit. I will get this asked about soybean N credits. I mean, you could calculate an N credit, potentially if you looked at the difference between continuous corn and corn following soybean. The issue with the soybean N credit is we can give a value. I'm not sure how accurate it is. Some people would say maybe a pound of N per bushel. It's probably way too high. 30, 40 pounds is probably about accurate. But the issue is, there really isn't any N credit, and it's actually built into the calculation. I don't need it if I'm gathering data from corn following soybean, looking at that N response. That N credit is built in to that system. So, that's why I haven't really given one. Some of the recommendations you'll still see in the state for some of the other crops, a credit, and that's just because we haven't developed any system like this with that. So that's been a difficult one, because I'll get asked that sometimes, and there just really isn't a good value, because, depending on where you're at in the state, there may or may not be a credit. And kind of looking at some other things with one of my students' projects right now on some of this crediting to see if there's another way to look at some of this. Residual nitrates, we do have a way to credit those. It really only works, though, in situations where we would expect some residual nitrate. So continuous corn manure situations, there might be an area where you could look at a 2-foot nitrate test to see if there would potentially be a credit. And I've actually seen where that does work. Western Minnesota was the area we've typically focused on with the N credit, but there is some central, eastern, some of those areas, spring or even fall, if you're trying to look at sites that may be sites that are less responsive, that it might potentially work. But we have an average built in, and that's, sometimes you'll hear, I'll put out a news release talking about this. If we get situations where in the falls where we see more flushing of some of the nitrate, where the amount of N in the 2-foot sample is a little bit less, sometimes we'll talk a little bit about adjusting rates up, because there's 30, 40 pounds, particularly with the corn following soybean, that was pretty common for an average value that's kind of built in with that calculation. So I don't really use it, but there are situations where there might be some credits that you could look at with that. And then again, talking about rotations, I think cover crops right now is the biggest question mark, because whether or not you're just starting in cover crops, whether or not that's going to be different versus later. There's a lot of questions in terms of time factor, and you start adding in cereal crops. Specifically, if they're taking up nitrogen and not getting it back, that is we've seen situations where corn, soybean with cereal rye, particularly in some of the early stages of establishment, have needed as much nitrogen or pretty close to corn following corn. So they said that's a problem. You start adding all these things in there, then it starts to kind of looking at these calculations. You have a lot more uncertainty in what you can find. So there are some outputs. If you're going online, you can play around with. These are just some examples. You've seen the one at the bottom left. I mean, that's just essentially the MRTN output. And the one thing online is you can go on the tables that I give, and I'll talk about this. I do some rounding, but online you can be more specific in terms of the rate. The upper right would be this is looking at the optimum nitrogen rate versus optimum yield. I'll come back to this because, I mean, this is kind of the question is, with increased yield, do we see increased optimum N rates? And the bar graph at the bottom is just looking at a frequency distribution of essentially the number of sites that fall within certain ranges of economic optimum nitrogen or MRTN values. And generally where we're at, looking at kind of where MRTN, it's kind of right here. So in most cases, if you look at our data set, the predicted MRTN is generally about 2/3 to 3/4 of the sites fall below that value. So in most cases, I said we're not using the average, the way this thing calculates. We're generally going to be slightly higher than that on an average basis. And that's one of the things why I like it, for at least for planning purposes. We should be pretty good for most situations. I mean, there's certainly some that we see that need higher nitrogen, but it's not always the easiest to predict it across a number of the sites. So it's something you can kind of play around with if you're kind of wondering where the data falls in. I mean, some of this output is out there. You can kind of look at that just with some of that predicted values. And as I do tend to look at look at that because we've seen it adding some of the more recent years, or if you get some of the really wet years, then it tends to, if you say 2/3 of the sites fall below, sometimes that'll fluctuate just based on the data we add. So here are the yearly trends. I mean, this is looking at the data. I mean, I compute this every year, just looking at the yearly averages, just to kind of see if we get wet and dry years, how that affects some of our data. Certainly this isn't the best comparison because, I mean, it's specific to the sites and we don't have the same sites every year. So kind of looking at trends on a site-by-site basis, it'd be nice to have, 20, 30 sites where you have nitrogen response trials every year. That same site to look at the comparison. So there can be some skewing with this, but in general, the trends, and this is why I took out everything below 2,000. I mean, with continuous corn, you look at a lot of our averages were for the MRTN were around 150 pounds N up to that point. And you look at 2,000, I mean, you kind of look at, I can draw a steady line through this, essentially showing an increasing trend. We see this is like 2021 that we saw some drops. So we still do see some years where we see lower than average nitrogen requirements, but the general trend has been kind of increasing with continuous corn, and that's why I got rid of everything below 2,000. And, this would be good probably this time around when I add the 25 data in, we'll probably look at potentially the data with or without, 2001 through 2005. So a lot of times I'll just delete the data out and just see what that does. And if it doesn't make a big difference, I don't delete it. And the corn following soybean data, I still have data in back to 95, and a lot of that's because I look at the data with and without, and there isn't a lot of difference. Though I'll probably go in and look at it here because about every 5 years I kind of go through and look at, taking out 5 years of data and just seeing what that tends to matter. And this is just, continuous corn following soybean. The thing I want to say about this, we did see a jump here. But a lot of this is, about the time that Fabian Fernandez started. And that's one of the things, the more data you add, you're going to see it adjust closer to, when you get those larger pools. And that's what the bars represent, essentially, are the number of sites with that. So that's where if you look at the last 5 years, I've probably seen the largest increases in corn following soybean. And a lot of it's just been because wetter years, more sites. So that's kind of one of the things, again, that I kind of like to look at within this just is taking some of the data out. I mean, this is just an example of this. This is looking at the corn data. This was probably 5 years ago I did this, or was it 2021 actually, looking at the 20-year data versus the 10-year data, and you can see a fair amount of difference between the more recent and the earlier stuff. I mean, if you go back and look at this, I mean, but you still see there's a lot of dips and valleys in that too, and that's why I don't like to throw out any more data than I have to, just to make sure we have a critical mass of sites to give us a better calculation. Corn following soybean, this was 5 years ago. I mean, if I look at the 10 or 20-year data, and averaged about the same. Now, if I think I look at it now, the last 5 years, we'll probably see some differences with that, but I haven't done that at this point. So that's why, if you look at some of the earlier data, why the corn following soybean, I just haven't thrown it out because it's been more consistent over time in corn on corn. I mean, I think a lot of the difference we see with corn on corn, especially recently, really is looking at some of the yield potential now with continuous corn increasing. The more residue we have out there really does impact things because of higher yields. That it makes a lot of sense to me that more residue really has a potential for looking at greater tie-up of nitrogen, potentially increasing our nitrogen requirement. So, I mean, it makes some sense to me why you start looking at 2000, why we saw a steady increase, especially with BT hybrids coming into play and just seeing a better quality crop out there with less issues with stalk damage and disease, that the more material you have, the more that would creep up over time. So parent material, and this is what I'm looking at now. This is looking at essentially the far southeast, so looking at the karst region, the loess soils. So this would be silt loam soils versus glacial till soils. I mean, I've been wondering about this since about 2015. I calculated this a couple of years ago, and we didn't really see much of a difference, maybe 4 or 5 pounds. I mean, now this is looking at soybean following corn. I mean, this is some of the things I can do with the data set, looking at a difference, a 15 pounds difference between the loess and the till. And then looking at corn, soybeans, seeing corn, seeing close to 20-pound difference with that. And if you look at the profitable range, you look at kind of the two combined together. I mean, the way you could look at doing this is that the southeast soils tended to be more towards the lower end of the profitable range, while most of our till soils seem to be more towards the upper end of the profitable range. But, you know, looking at the data, if we've got enough numbers right now, we'll look at splitting it out. Irrigated is going to be more because irrigated sands need more. And that's why the recommendations are higher with that. But it's been one of the things that I've been trying to do, say the last 2-3 years, is to try to compile some of this data together, the more recent data, because I think we're looking at a lot of our sites, we've been pretty close with the recommendations we have if we have at least 3 splits of nitrogen to kind of keep it within where our guidelines are. But it's one of the things we really need to look at this point, just see where things are at, because they're going to be slightly higher just because we don't see the end carryover that we would in some of these situations. So that's why it's adjusted up, but that's not in the MRTN calculator right now. So a couple things I really like to stress is that it's a starting point. You know, it's nice to be able to start somewhat low and adjust up for the year because the problem with nitrogen is what I said before. You make the decision 6-8 months ahead of time when you don't know the weather. Once it's out there, I mean, the only way to get it out of the soil is really to have a crop take it up. So if the crop's not going to utilize it, it becomes problematic. So, you know, like insurance nitrogen, you know, with the options we have with in-season management, you know, looking at, I think we've got more flexibility. I mean, the issue is always cost, though an extra pass to the field is an additional cost. And a lot of times in the spring, I mean, your nitrogen, so I'll look at economics, fall versus spring, I'll factor in maybe a 10% increase in cost for spring versus fall to kind of look at, you know, some of these options. But really the issue, as I said, I need a starting point. And that's really how I view this, as a starting point, at least to start then walking through what I know about the nitrogen cycle and what I know about management to make some adjustments to give me an idea of where I think I need to be. Because I know there's soils out there. I mean, I go to our research site at Waseca, the Southern Research and Outreach Center, where there's some really tight soils that need more nitrogen. You look at corn following soybean, it isn't very uncommon to see some of those respond to upwards of 200 pounds of N, and a lot of that's due to the excessive denitrification in a lot of those soils. It isn't that they're being leached out of the profile, and that's one of the things with a lot of this data. I don't have water quality numbers with this, but if you look at our MRTN values, you look at an individual site, that nitrogen loss really doesn't start to occur until we start really exceeding the MRTN value of the site, whatever it is. So I could have a site that's 150 pounds in, I could have a site that needs 200. If you had tile line measures in those two sites, you may not see a whole lot of difference in nitrogen concentration, just because a lot of the difference really, you know, for a lot of our soils, to me, is coming through denitrification. I mean, that's a big issue with some of our heavy soils. So we're losing more likely the atmosphere than it's going down through the tile line. And a lot of times, said you look at the MRTN, that tends to be a very good economic rate. How am I doing? 10 minutes, okay. So, you know, again, it's impossible to know. You know, I can calculate from some of this. I mean, we can calculate factors. I mean, you look at those old factors like 1.2 pounds of N per bushel. I mean, yeah, typically we could calculate some of this, but it just doesn't carry through. I mean, and if you look at the data, you know, I'm just kind of to wrap up here. I mean, this is looking at a couple different things that I've been playing around with this data set. The bottom is looking at just a general trend in economic optimum nitrogen rate and yield. And if you look at, there's somewhat of a trend, but there's a factor in here you can't read. It's the R squared value, which essentially gives me an indication of how much of the variation of Y can be explained in the variation of X. In most cases, it's only about 10%. So it's one of the things that, with increases in yield in that relationship potentially with optimum nitrogen rate, I don't know if there's an actual relationship there or if if they themselves are being affected by similar things that would affect high yield potential at a given site. So they might be related to each other, but not necessarily a causational relationship. So that's always kind of the thing looking at this is if you see this and you see these nice little lines here that look like they're increasing, unless this R squared value is, above 0.5, 0.7, I mean, that's a pretty strong relationship. If it's below that, to me, it's more of kind of a general, something that might be occurring in relation to each other. And looking at it, it's more of a shotgun blast, and that's why we don't use it. Because, some of this, just, again, I don't think they relate all that well to each other just based on a lot of the data. Really the thing I've been looking at is, the nice thing, looking at some of this data, I can dig through and look at like the yield potential of the control, and I've shown this before. Some of you may have seen me talk about this. Looking at individual sites and kind of what explains some of the higher optimum nitrogen rates, it's really essentially what the soil provides. So this yellow dots are corn following corn. The maroon dots are corn following soybean. I mean, you look at, they fit along the same relationship. These are all Minnesota soils. So, if I could kind of get a good general handle on a site and what, potentially I could produce without nitrogen, it give me an idea essentially of how to adjust some of these sites within our database to get more precise to a closer target of that MRTN value. I mean, this is just an example of that data where I've generated an EONR of when the yield of the control produces less than 50% of the maximum versus greater than 50% of the maximum. That's a 60-pound difference in the MRTN. So there's some things there I've been thinking about the last few years. I mean, if we had some growers, you leave a few small areas of the field just to look at what your soil can potentially produce. If that's consistent over time, it might be a way to kind of look at if we're really trying to hone in on areas, particularly if you're in some programs that really kind of pin you into looking at university recommendations, you want to make adjustments. This might be a way to do it, just to look at whether or not areas that might be more or less responsive. I mean, the interesting thing, you look at this, I mean, it really would show essentially that the poorer areas of your fields probably need more nitrogen. It isn't necessarily those higher yielding areas that need more nitrogen, things are good there, that they probably need less in those areas. And that gets to that question, do you feed the rich or starve the poor? Analogy with nitrogen that, looking at it, we get a higher return on some of these areas and you need more nitrogen with some of those areas that are probably more poor yielding areas of the field. So just wrapping up here, current guidelines, this is the update through 2025. Again, I'll be looking at updating this, but I've been trying to release the updates in the summer. So you're probably not going to see any changes until June or July of this year. The numbers, looking at how much they went up, corn, soybean, everything was within about 5 pounds when we added the 2020, this is 2020 through 2024. So we'll see what happens with 2025. I mean, I actually thought it might kind of be about the same or adjust down a little bit because with the dry years, it looked like we needed less in, but things tended to creep up a little bit with some of that 2024 data. This is all rounded though. So if you go in and look at the calculator, you calculate these price ratios, which are what I've done here is for $4 corn. What these price ratios represent are 30, 40, 50, and 60 cents per pound N. So that's why I did 0.075 instead of 0.05. It's an easier calculation with roughly $4 corn to get that ratio without actually having to make the calculation. So, I mean, things did go up. If you are using manure, though, we do not use this system. So I just want to bring that up. We actually need to look at the manure guidelines at some point here since the continuous corn did adjust to see if we need to up those. Right now, the max we recommend for corn on corn is 195. I'm guessing it'll go up a little bit more. So just kind of to wrap up, yearly trends. Again, we've cut some of the continuous corn data because of that. We'll see what happens with soybean. Response have been high. I mean, that's a problem. Again, I mean, it'd be nice to essentially have an answer for everybody out there to kind of this is what you should apply, but we just don't at this point. And it's kind of a problem. It said we look at dividing this out, but we're a little limited by what data we have. But at least, again, with corn following soybeans, things have been more consistent. looking at it, just what we need in the field, that's really the key. I mean, what you know about your fields, I mean, really goes a long way. But again, it's really having a starting point has really been the key, and that's really kind of where I view this. So again, updates wise, I mean, I would expect probably seeing something maybe in the summer, because that's kind of where we've been trying to release things here. We'll get everything gathered here for spring and look at it. I would suspect, I mean, if you're applying near the upper end of the profitable range, well, still generally with any increase we've had, we've been within the profitable range on a yearly basis. So questions? You want me to take the first one, Tim? So why aren't organic matters considered in the U of M rate? And honestly, I had that slide in here, and looking at OM versus the nitrogen requirements, and within a field. So say I've got a field with a lot of variability in organic matter, I probably could use an organic matter map to make some adjustments, because it goes back to what I showed before. It's when I went back and I showed where the less than 50% versus greater than 50% yield potential would kind of follow, I think, some of those patterns. The problem is you start going across fields, you have an issue. So I know a few of you kind of central Minnesota areas where you have the pothole regions, high organic matter in those areas. If you'd use just a simple organic matter as a tool for making adjustments, a lot of those areas have a lot of denitrification, probably need more N. So that's kind of the issue with it, is I think within fields you probably could make some adjustments, but across a wider range of fields, I don't know if it really works as well, because the areas that we tend to see really high organic matter are areas that are poorly drained, that just don't tend to break the organic matter down as quickly, which essentially is denitrification with that. So it is kind of an issue with it, and why when I look at the data, I mean, I look at OM versus that, there can be some patterns maybe within fields, but they aren't huge when it comes to the differences, and it isn't enough where I would change the recommendations. But some other crops like beets I know do use or have used it in the past. Just with corn, we've never been able to shake anything out where it makes sense to make a recommendation for it. Is that my only one? Is there one here in the?
Can you turn it on?
And I'll have to repeat the question too, probably.
No, I wanted you to talk a little more about the cover crops. You were kind of indicating maybe that some situations there was a need for more nitrogen, and then also you talked about the residue and the short hybrids. A little more discussion about that is what you're seeing as far as needs or I don't know, whatever research I have with that.
Okay, I'm going to start with the short hybrids first, because I think that's kind of the simple one. And the thing is, we don't have a lot of information on short hybrids in terms of uptake right now. So that's one of the things I'll be interested to see. There's been some that have kind of shown similar uptake, I think, for some of the data that Jeff Coulter talked about this a couple weeks ago. So we'll kind of see, because to me, if the amount in the grain is the same for the grain N concentration, the removal is about the same. Really, the only difference there could be essentially if there's any difference in the amount of nitrogen taken up in the plant itself. So that's kind of what I'm curious on. And if they're planting them at greater densities, I mean, essentially you might see about the same thing when it comes to uptake. But we'll see, because I said I don't know a whole lot about that at the point. That's a big question right now on that, and whether or not, if you can get a situation with less biomass, if you have the same amount of nitrogen concentration in the stover versus a taller one, theoretically, I mean, the uptake should be less. So, potentially that the concentration a little bit less, but if it's all about the same, then it's not really going to matter. I don't think. So that's kind of what we'll see on a per acre basis. The other question was on cover crops. So that's what we had a study. That's probably been 6-7 years ago. We were looking at some different covers, cereal, rye. But this was going into the first years adopting the covers. That if you looked at a lot of the data, it took more nitrogen if we were following cereal rye than without. So that's kind of the question that I don't know how long it would take potentially to get some cycling of some of those nutrients, because it doesn't seem to be happening initially the first year. But over time, I mean, that's one of the things we've never been able to address, is because I think there's more going on than it isn't necessarily completely related to just the biomass that's out there with the covers for the recycling. That there might be some other factors where the soil's storing some released ammonium and some other nutrients that, I mean, it can store some. That's what, again, we're looking at right now with one of my students. to see that there might be some cycling that occurs at a later date. I just kind of, I mean, if it's your first years in the field, it's one of the things I would watch is I don't think we get a good recycling of nitrogen because, I mean, you look at cereals, I mean, technically green materials should have a lower C to N ratio where you should get some mineralization, but we just haven't really seen it. So that's the only thing that said just to be aware of, and that over time you might start getting a benefit. But initially, the stuff we have, the first years of adoption, looking at at least some additional, and particularly the more biomass that's out there. But it's really biomass driven on that. With it, in the years we've gotten a lot of biomass, it's taken more nitrogen following cereal rye specifically. So it just depends on how much is out there because some of that still can be consuming some of the nitrogen that's in the soil. So there's been some question marks with that, and they said, I don't know, you can't really use a calculator just because of some of those issues with it, that there might be some tie-up.
Dan, are you going to be with us all day today?
I'll be around till probably noon. I got to get back for something for my
Do we have
kids here in the
additional
afternoon.
questions?
So
May I see you?
yeah, if you have any additional questions,
good.
just hit me
Right.
up. So
Let's give Dan a hand. Thank you.